Welcome to Get Your FRQ On. This question is from 2010, Test B. It's question 5, and it is not calculator active. In the question stem, we're given a differential equation, and in part A of the question, we are asked to sketch the slope field for the provided 12 points, and to sketch the solution curve through the point 0, -1. First, for a slope field question like this, you're going to want to use the differential equation to find the slopes at whatever point you need. So do that. Sketch your slope field. Notice that because we're dividing by y here, y equals 0 is never allowed to be used because we would get undefined slope, and we're not going to do that. So there's no marks here. Notice there's no points there either. And then to draw the solution curve through the point 0, -1, we would have, if we follow the slope field, a straight line. Notice, once we get to the point -1, 0, we don't really proceed from there with our solution curve because that would require us to go through a point whose y-coordinate was 0, and the differential equation is not defined there. So we're just going to stop at -1, 0. In part B of the question, we are asked to describe all points in the xy plane, y not equal to 0, for which dy dx is equal to -1. All right, so using the differential equation, if we want dy dx equals x plus 1 over y to equal -1, that would require y to be the opposite of x plus 1. All right, so that would be our answer, right? That the differential equation will equal -1 for all points xy on the line, y equals the opposite of x plus 1, such that y is not equal to 0. In part C of the question, we are asked to find the particular solution y equals f of x, using the initial condition f of 0 equals -2. So we're going to use separation of variables here, as would be the expectation when solving a differential equation like this. In fact, if you don't use separation of variables, there's a good chance you could fail to earn any points on this part of this question. So separating the variables, we get y dy equals x plus 1 dx. Then we anti-differentiate both sides. And after anti-differentiating both sides, we get 1/2 y squared equals 1/2 x squared plus x plus a constant. If we multiply both sides by 2, we can clear the fractions, and we get y squared equals x squared plus 2x plus a constant. Then we can use the initial condition f of 0 equals -2, plug in 0 for x, -2 in for y, and we get 4 equals c. So our constant of integration here is going to be 4, which means we now have the function y squared equals x squared plus 2x plus 4. Typically, we would have to solve this explicitly for y, so we will want to get rid of the square. Taking the square root of both sides, we get the square root of x squared plus 2x plus 4. But since f of 0 is -2, we have to choose the negative version of that square root.